Welcome to the class. So, this class is of basic concepts regarding electronics. What are the electronics? Why we are using the electronics? What is the difference between electrical and electronics? What type of components we are using in a electronic circuit, etc. So, electronics is a branch of physics, engineering, technology, and applications that deal with the emission, flow, and control of electrons in vacuum and matter. Or we can say that electronics is the study of movement of electrons in a semiconductor, conductor, vacuum, or a gas. So, main difference between electrical and electronic circuit is that electrical circuits have no decision making processing capability, while electronic circuit do. An electronic circuit simply powers machines with electricity. So, this is the basic difference between electrical and electronic circuits. Electrical circuits have no decision making capability, but electronics circuits do. So, before we go into study electronics here, we must know difference between the electrical and electronics. And now we are going to study about valence electrons. What are the valence electrons? Why we are using the valence electrons in electronics? So, the electrons in the outermost orbit of an atom are known as valence electrons. The outermost orbit can have a maximum of 8 electrons, that is, the maximum number of valence electrons can be 8. The valence electrons determine the physical and chemical properties of a material. These electrons determine whether or not the material is chemically active, metal or non-metal, or a gas or a solid. These electrons also determine the electrical properties of a material. On the basis of electrical conductivity, materials are generally classified into conductors, insulators, semiconductors. As a rough rule, one can determine the electrical behavior of a material from the number of valence electrons. Or to know about the valence electrons, we should first know about the atom, because it is all about the structure of an atom. An atom is formed of electrons, protons, neutrons. Nucleus of an atom consists of neutrons, which are uncharged particles, and protons, which are positively charged. Electrons are present around the nucleus of the atom. These are negatively charged. The electrons situated in the inner shell of an atom are the core electrons of an atom. The number of electrons and the protons are always the same. Electrons are arranged around the nucleus of an atom. This arrangement is sometimes called as electrons clouds. So, some key characteristics of the valence electrons: they exist in a outermost shell. So, this is the important concept here. They exist in a outermost shell only for main group of elements. They can exist in an inner shell for transition metals. They can absorb or release energy in the form of photon. These electrons also determine an atom's electrical conductivity. Now, if the valence electrons exist in the outermost shell, and we know that the maximum number of valence electrons in the outermost shell can be 8. Now, let us study one by one. In the case 1, suppose if the number of valence electrons of an atom is less than 4. If the number of valence electrons of an atom is less than 4, that is the half of the maximum 8 electrons, the materials is usually known as a metal or a conductor. Example, you can take it as sodium, magnesium, and aluminum, which have 1, 2, and 3 valence electrons respectively. Now, if I go for the second case, where the number of valence electrons of an atom is more than 4, the material usually known as non-metal or as an insulator. Examples we can take it as a nitrogen, sulfur, neon, which are 5, 6, 8 valence electrons respectively. In the third case, the number of valence electrons of an atom is equal to 4. That is exactly the 1/2 of the maximum 8 electrons. The metals has both metal and non-metal properties and is usually called a semiconductor. Remember this? When the number of valence electrons of an atom is 4, that is exactly the 1/2 of the maximum 8 electrons. The material has both metal and non-metal properties and is usually a semiconductor. Examples you can take it as a carbon, silicon and germanium. Now here, once you know how to differentiate between the metal, or you can call it the conductor, non-metal, which is nothing but the insulator, and a semiconductor. Now let us go for the next part. So in the electronic circuit, we usually use the components to connect. So what are these components are called? How they behave? Now there are two different type of components which we are using in the circuits, electronic circuits. One is known as the active component and second one is known as the passive components. There are two components which we are using in the electronic circuit. Active components can inject power into a circuit. You remember this? Active components can inject power into a circuit and are capable of electrically controlling and amplifying the flow of electrical current, where the passive components cannot. So the active components means the components which you are using to inject power into a circuit. Now what are the passive components? Passive components either consume energy or store energy. As the active components inject power, passive components consume this power or store this power. So a simple way to test whether the component is active or not is to measure the difference between its input and output signals. If there is a decline in power, the component is passive. If the signal is amplified, it is active. All electronic circuit must contain at least one active component, and most electronic device contains both active and passive components. Active components require a source of energy, typically in the form of a direct current, in order to perform their specific function. Most active components consist of semiconductor devices such as diodes, transistors, and integrated circuits. So these are some active and passive components. Now let us study one by one. What are the different types of active components we have or passive components we have, which we are regularly used in the circuits. So let us begin with one by one. I will take first active components. So in the active components, you know, active components are used to inject the power in the circuit. So first one, you can take it as a transistor, which is regularly used in the circuit. It looks like this. It consists of 3 legs here, which we are calling it as a legs. Now, the transistor is represented in this format in the circuit, which is the basic symbol of a transistor. Here there is an arrow mark which represents the flow from positive to negative direction. The transistor mostly used for amplifying electrical signals or as a switching device. You remember this? Transistors are mostly used for amplifying electrical signals or as switching device. So here, when you get a transistor, you can read the properties of the transistor by knowing the number given on the transistor. And by using the symbols in the circuit, you know whether the given transistor is a NPN transistor or a PNP transistor. The second one, that's called the diodes, which looks like this. This is the diode which is easily available in the market or we are using in the electronic circuit. So what is the use of a diode? Diode permits electricity to flow in one direction only. You remember this. Permits electricity to flow in one direction only. That means it is going to convert AC into DC. Now here you can see two parts in this, two colors. One is black color and second one this white strip here. Usually the white strip here is known as a cathode, which is referred as a negative sign in the circuit. And the other part, a black portion of this one, is known as anode, which is a positive. The third one, we can go as an integrated circuit, which is used to perform all the kinds of tasks in the circuit. So here you can see this integrated circuit. This is the usual symbol of a integrated circuit which is available in the market. Sometimes it referred like this in the circuit or sometimes it is referred like this in the circuit. Next one, displays. Display devices such as LCD, LED and CRT displays, which display the output signal. So this is one of the active component. Usually we are calling it as LCD and LED. Next one, the power sources. Power sources such as batteries and other sources of alternating current, AC or direct current. Here you can use any type of a power sources of alternating current or direct current. Usually it is represented as this symbol. This is the symbol of a power source in the circuit. Now next go for the passive components. Passive components can influence the flow of electricity running through them. For example, they can resist its flow, store energy for later use, or produce inductance. However, they cannot control or simplify electricity themselves. Out of many passive components, here I am discussing only few which we are using regularly in electronic circuits. The first one is a resistor. Resistor, the flow of electrical current in a circuit. Resistor resist or oppose the flow of electrical current in a circuit, which are used to lower voltage. So usually the symbol of resistor is like this, or sometimes it referred like this. Here you can see a regular symbol of a resistor with one arrow mark. So this is used as the variable resistor. This is nothing but a variable resistor. Another one you are seeing here, a symbol of a resistor along with an arrow mark, a crossed arrow mark. This is also known as variable resistor. The second one, capacitor. Capacitor is used in the circuit to store electrical energy and can release it later when needed. You remember this? Stores electrical energy and it releases it later when needed. So this is the normal symbol of a capacitor in the circuit. Sometimes it referred like this, a positive sign and a negative sign. These are the different types of capacitors which are available in the market. Next one, inductor. Inductor is used to store electrical energy in a magnetic field, allows direct current, that is called the DC, to flow through it but not alternate current. So these are the some symbols. Here this is a symbol of a inductor. These are some components inductor available in the market. So here you can see the difference between capacitor and inductor. It is a copper wounded one. It is a copper wounded one. This consists of a electrolytic capacitors. So you remember this. Capacitors are used to store electrical energy. Capacitors are used to store electrical energy and can release it later when needed. Inductor stores electrical energy in the form of magnetic field. This is the difference between a capacitor and a inductor. Inductor stores it in the form of a magnetic field. Now go for the last one, that is called the transducer. It converts an input signal from one type of energy into another type. Sensors are a type of transducers that converts physical action into an electrical signal and vice versa, like electrical energy into light or heat energy, or electrical input into mechanical output. Now let us go a little bit deeper side of a resistor, as it is the basic component which we are using in the electronic circuits. Resistor. We know that it is used to resist the flow of electrical current in the circuit. To control the flow of electricity when necessary, it is used. It is highly linear. As the voltage changes, the current through them changes linearly. Whenever you are connecting it in a circuit, the electron go to it and it slows down the electrons. There is a flow of the electrons. It resists the flow of electrons so that you won't have nearly as much as going through it. It works on formula called V equal to IR. V equals IR, or voltage equals current times resistance. It helps to do when you are trying to set the current, how much current and what voltage is going to be through and across the resistor. Figure out the power and dissipation capacities and also its tolerance. Most resistors have the tolerance of 5%. And finally, the thermal coefficient, that is, whether you are in a hot or a cold place. You have to refer this while you are connecting the resistor into the circuit. It won't get affected with the frequency. All of them have a little bit of inductance, a little bit of capacitance. Even during high frequency, you want to be making sure that your resistor has a minimum capacitance of minimum inductance. So this is some basic concepts regarding the active and passive components. You simply remember this. In the active component, you have the transistor, which is used to amplify signals. You are using diodes. In the transistor, you have two types of transistor. One is NPN and the one is the PNP. The arrow mark shows the flow of electrons in the circuit. Diodes, which is used to convert AC into DC, which is used to permit electricity to flow in one direction. You have two parts here. One is negative and the one is the cathode. Yeah, that is positive anode. Third one, you are using IC, used to perform all kind of a task, which consists of many legs here like this. So these are basic symbols which you are using in electronic circuits. Displays. You are using the displays as LCD and LEDs. Power sources, that means which are used to inject power into the circuit. You can use here AC or a DC power sources. So this is the general symbol of a power sources in the circuit. Next one, you are going for the passive components. Resistor, which is used to oppose the flow of charges in the circuit. Capacitors are used to store the energy. Inductor is also used to store the energy, but it is in the form of magnetic field. Now let us go for these two terms. So when you are using a resistor, we have to use the term called resistance. Or when you are using the capacitor, you need to take the term called capacitance. Or whenever you are using the inductor, you need to use the term called inductance. What is the resistance? Resistance is the property of a conductor which determines the quantity of current that passes through it when a potential difference is applied across it. A resistor is an electrical component with a predefined resistance. So, resistance is the property of a resistor. Resistor is the component. So, before you are going to use the resistor, you must know about the property of a resistance. That is, what is the value of it. Secondly, capacitor and capacitance. The property of the capacitor to store the charges on its plate in the form of an electrostatic field is called the capacitance of the capacitor. You remember this? It is the property of the capacitor to store charge on its plates in the form of an electrostatic field is called the capacitance of the capacitor. So when you are saying that is capacitance, you are saying about its property. Next one, last one, inductor and inductance. A capacitor stores energy in an electrostatic field, but inductor stores energy in a magnetic field. An inductor is a passive two-terminal electrical component that stores energy in a magnetic field when electrical current flows through it. So when you are saying the inductance is a property, inductor is the component. So when you are saying resistance, you are saying about its property. Capacitance is the property, inductance is a property, but resistor, capacitor or inductor are the components. Now next, let us go with the color codes of a resistor and how to calculate its value. So this is the usual picture of a resistor available in the market. It consists of 4 different colors. First, second, third, fourth, which you can call it as a bands, color band. First band, second band, third band, and the fourth one. So these colors have their own specific values. They represents its own specific values of a resistor. Now what are these values? How one can find out its values? So you must remember this table. So it starts with the black, brown, red, orange, yellow, green, blue, violet, gray, white, gold and silver. It consists of these 9 colors along with these 2. A tolerance, which represents the tolerance. So how to remember this? How to remember these color codes? You remember one statement. B. Roy of Great Britain having very good wife. So this is the easy way you can remember the color codes. B. Roy of Great Britain having very good wife. So what are these colors represents here? So if the first band of the resistor, here it is, represents the first digit, which is nothing but 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That means the black color represents the first digit. Black color represents 0, brown 1, red 2, orange 3, yellow 4, green 5, blue 6, violet 7, gray 8, white 9. In the same way, the second band consists of a second digit, which is the same as the first one. But the third band, here you can see, the third band represents the multiplier. The multiplier. It's the multiplier for the first and the second digit. So first one is black 1, brown 10, red 100, or you can remember this one as 10 to the power of 1, 10 to the power of 2, 10 to the power of 3, 10 to the power of 4, 10 to the power of 5, 10 to the power of 6, 10 to the power of 7, 10 to the power of 8, 10 to the power of 9. This is the easy way to remember the third band as a multiplier. Usually, the 10 to the power of 3 is known as kilo ohms, and 10 to the power of 6 is known as mega ohms. So, this is the first class for the basic concept of electronics. Thank you.